Hello everyone, welcome to yet another video of Smartgrid. Hope you all doing well in your studies. So in today's video, we are going to see about a case study on Smartgrid implementations. So in this interactive video, our students, our mentees are going to discuss or going to have a casual talk about a Smartgrid implementation. They are going to discuss with a case study. So they have taken a problem and they have given an in-depth understanding from their point of view. Hope this video will be very useful to you. Let's get into the video.
I'm Mithun. I'm going to talk about V2G. Basically, V2G is an technology enable electrical vehicles to send electrical back to power grids. And now going to talk about working principles. Bidirectionally charging system allows energy to flow from grid to EV and back from EV to grid. And components involved in that are EV bidirectional charging capabilities and smart meters and charging enabled with V2G functionalities, grid operational provider.
I'm going to talk about use cases, load balancing, emergency power supply and also energy arbitrage. The challenges in V2Gs are battery degradation, high infrastructure costs, lack of standardization, regular and policy issues. Current V2G implementation in Nissan Leaf V2G trials and also project in Japan, UK and USA. The future scope of V2G are integration with smart grids and renewable energy, role in distributed energy system and also potential for management like electrical buses.
I am Dhanush Raj. I am talk about how does to electricity moves on V2 grid. First, let's go through the very basics of how electricity behaves in the grid. It is always takes the shortest possible way to the nearest location, where it's need vehicle grid to grid changing devices absorbs the electricity from the car battery and simple just passes it back the grid where the continuous journey of the nearest location where it is the needed. When not changing the possibility of balancing grid ends when the battery is fully charged. With V2G, the grid balancing continues the full time the vehicle is plugged in. Private charging at the home work in ideal V2 grid in the time the vehicle is connected to the charger is wrong.
Hello everyone, I am going to tell about key points. So environmental impact, reduce the dependency on a fossil fuel by integrating a renewable energy sources, helps a balanced grid loading, reducing the need for a peaker plants, often a carbon intensive. Efficiency energy management, EVs act as a mobile energy storage useful during a peak demand times, enhance a grid stability and resilience. Economic benefits, EVs owner can earn money by selling excess energy back to the grid, reduce the energy costs for both utility and consumers. Technology and infrastructures require smart grid system by directional charge and communication protocols. Still in early stages of deployment is a challenge. Challenge and concerns. Degradation due to frequent charging and discharging. Regularity requires a sufficient investment in our infrastructure. Future potential can play a major role in a sustainable urban planning. Integral to the smart cities and IoT driven energy system. Potential to support a disaster recovery by supplying a power in an emergency. Advantages of a V2G grid stabilization. EVs can supply a power during a peak demand, reducing strain on the grid. Environment benefits support a low carbon energy system, reducing a reliance on fossil fuels. Disadvantage of V2G, battery degradation. Frequent discharge cycles can reduce the lifespan of EV batteries. High infrastructure costs require investment in bidirectional charge, smart meters and software system. regulatory and standardization issue, lack of consistent policies and technical standards, widespread adoption, limited awareness. Many EV users are unaware of a V2G benefits or due to a technical complexity. Thank you.